Welcome. Thank you for choosing our MySQL Database Administration and Development course. We hope you enjoy it. In this course, we're going to talk about the internal architecture of the MySQL Database Management System, which going forward, we're going to simply refer to as MySQL. In addition to looking at the internal architecture of MySQL, we're also going to look at the basic principles, the fundamental foundational principles that make a database management system what it is. And once we've laid that foundational groundwork, we're going to look at how to design a database and then develop it within the MySQL environment. Then, having a database, we're going to discuss how to keep it secure, how to secure the server, and how to secure the data. And then the routine maintenance that accompanies administering any kind of database system, from backing up the data to performance enhancements to monitoring and so on. Once we've covered these foundational principles of administration of the database system, we're going to look at a couple advanced topics. Data replication, that is moving data in near real time from one server to another server. And high availability, ensuring that our database, the database that we're responsible for as DBAs, that database will always be available for the business. So this begs the question, why study MySQL or any other database management system for that matter? Well, because databases and data in general, but the database specifically, is generally the center of any business. Whether it's an online business, a brick and mortars business, a nonprofit, government agency, data is at the center of that organization. It is the lifeblood of the business. And MySQL is the most popular open source database management system currently in use. And not only that, but MySQL is number 3 overall in the database market, with Oracle and Microsoft's SQL Server holding the number 1 and number 2 spots, respectively. Also, MySQL is part of the LAMP stack: Linux, Apache, MySQL, and PHP. MySQL is part of the LAMP stack, a very popular collection of technologies that some estimate currently support some 80% of websites on the internet. So what is a database? Well, a database is simply a container of data, of information. And we'll use those two words interchangeably, but technically, data is not information. So a database is a container of data, of information that's organized in some way so that we can retrieve that data quickly. Now, a database can be as simple as a well-organized stack of index cards or a notebook with information that's well organized on different pages of the notebook so that we can find it quickly. But a database management system hides from us all of the complexity, all of the plumbing that's necessary for the storage of the data and the mechanisms that are used to find and retrieve and return that data to us. And through this level of abstraction, we're able to store just about any kind of data that we're interested in putting into the database system, and then finding that data, retrieving it, and using it within our applications however we see fit. That's the database management system. So the database management system, MySQL, contains databases. The databases contain tables. The tables contain columns. The columns contain the data. When we take a collection of columns, a tuple of columns, that represents a row in the table. One row in the table is an instance of some related data. Well, database management systems have fundamental principles that define them, and ACID is one of those fundamental principles that define a database system. The acronym refers to atomicity, consistency, isolation, and durability. When we talk about doing something to the database, whether that's inserting data, changing data, a combination of the two, deleting data, a combination of any actions that we want to occur on the database, an ACID-compliant database must perform our collection of actions as a single unit. And if it is unable to execute our collection of actions as a single unit, it must undo any part of that collection of actions to put the database back into the state it was in prior to attempting to execute that collection of actions. So the atomicity of actions means if given some collection of actions to take against the database, they either need to all occur successfully or none of them occur. Consistency refers to the database protecting itself from actions that may corrupt the data. Isolation refers to the ability to have multiple users working within the database simultaneously without impacting each other or the data that each of the users is working with. Durability protects the data from system failures, so that if we make changes to the database and the server, for whatever reason, fails, those changes that we believe were successfully completed on the database are recorded somewhere so that the database will be in a consistent state with our changes recorded, even in the face of complete failure of the system. So how is it that MySQL implements these ACID principles? Well, we haven't gotten there yet. However, of the multiple storage engines that are available for use within the MySQL system, only one, InnoDB, is ACID compliant. So keep that in mind as we move forward. Within the MySQL database running the InnoDB storage engine, we get transactional support either implicitly or explicitly by using transactional control statements within our SQL code. All transactional statements are written to the log and then to disk. The consistency principle is supported by the binary log and the locking system within the database. Again, locks ensure data integrity by isolating the transactions. So we have support for the isolation principle. And the durability principle is again supported by the binary log file that records all actions against the database. MySQL is unique in that it allows the use of different storage engines to support different types of applications for the database. In fact, we can not only choose which storage engine to use, we can mix the storage engines within a single application, which allows an enormous amount of customization for the application. MySQL runs on all of the popular operating systems, Linux, Solaris, Windows, Mac, and so on. And again, one of the most powerful features of MySQL are the different storage engines that we can apply to our problem, to our application. And no matter which storage engine or mix of storage engines that we're using to support our application, the API, the interface that we use for managing the data within any of those storage engines is consistent. Again, this makes MySQL unique in the database world.